All right, in this next video, I'm going to cover page 5. So, part A, do the data provide convincing evidence? That tells me this is going to be a significance test. Those words, convincing evidence. They do actually say carry out a test. Very unlikely that they do that. Part B, interpret the p-value. That's something we haven't done in a long time. That could always show up. So I like that. That's on here. Okay, just to keep in mind, is this categorical? Is this quantitative? I see millimeters. That tells me right away it's quantitative because on the AP exam, you're going to have to decipher between the two. So I'm going to follow the 4-step process here in regards to my significance test. So state, I want to know if there's a difference in the blood pressure for somebody who took the calcium supplement versus a placebo. So I have mu sub C and mu sub P. Okay, so getting some context here. Does increasing the amount of calcium in our diet reduce blood pressure? There's a relationship. The relationship was strongest for Black men. Such observation do not provide causation. Okay, yes, experiments do. So they did an experiment. 21 healthy Black men volunteered. They were randomly assigned to 2 groups. 10 received calcium. The control group got a placebo pill. The experiment was double blind. So the subjects didn't know which treatment they received, and the people evaluating their blood pressure didn't know. All right. The response variable was the decrease in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Here's the data. So this is going to be, for the calcium, the true mean decrease in, I'm just going to abbreviate systolic blood pressure for calcium sup. True mean decrease in systolic blood pressure for the placebo. All right, my null hypothesis would be that there is no difference. Doesn't matter if you take the caffeine supplement or not, the blood pressure is going to drop the same. Now, for the alternative, we want to know, does the calcium supplement decrease the blood pressure more or reduce it more? And they said an increase is a negative number. An increase is a negative number. So that would mean a positive number means a decrease. So this would mean that this is a bigger positive than this. So this would be greater than 0. So this might decrease it by 10. This only decreases it by 5. That's why this is positive. They have not given us a significance level we're going to use. So we're going to default to our 5%. Okay. At this point, I'm on to the plan step. Random, the center of the sampling distribution. Notice there were volunteers, which is fine, and it's an experiment. So we have random assignment to calcium and placebo. So make sure it's very clear it's random assignment, not a random sample, because if you put random sample, you'll lose credit for that. I'm not sampling without replacement, so there is no need to check the 10% condition for the variability piece. So I'm going right to the shape. So here's the bad news. Sample size is not a big above 30 for either group, and they haven't told us about the shape, so we would need to create box plots for both of these. Same way we did it before, I'd type in the calcium differences into list 1, placebo into list 2, and I'd create some parallel box plots. Okay, so I'm not going to show that again on the video. So I'm just going to say blood pressure difference. I'm doing calcium minus placebo, calcium placebo, and the differences go from about -10 up to 20. Again, you want to just be as simplistic as possible with your scale and getting this down quickly. So calcium is approximately looking like this. and the placebo is approximately. So I know it's a pain in the butt to create 2 box plots, and it's just a small part of the 4-step process. It is what it is. So box plots, plural, show no strong skewness or outliers. So our sampling distribution, we can assume, is going to be approximately normal. So now our conditions are met. We're going to do a 2-sample t-test with degrees of freedom equal. All right, for once we have 2 different sample sizes, 11 and 10. So we take the smaller of the 2 sample sizes and subtract 1. So we have 9 degrees of freedom because we had 11 men in one group and 10 in the next. Okay, at this point we have our state and plan step done. We're moving on to the do step. So similarly, you're going to have to do 1 variable statistics on list 1 and list 2 to get the mean calcium difference was was 5, and the standard deviation for the calcium group was 8.743. For the placebo group, the mean difference was -2.73, and the standard deviation was 5.901. Okay, so now I'm setting up my sampling distribution. I believe there's no difference. When I subtract these differences, 5 minus this -2.73 is going to give me 5.273. That's the difference between these sample means. So that's where I'm getting this value from. And now I can set up my t-test statistic with 9 degrees of freedom, so subscript of 9. And I have the difference between the sample means, 5 minus a -0.273. That's my statistic minus my parameter, divided by my standard error. So we're adding the variances. What's my sample size for this first group? 10 for the calcium group and 11 for the placebo group. Okay, this results in a test statistic of about 1.604. I got to check something on my calculator as far as the p-value, so let me do that. TCDF 1.604 to large number. We had 9 degrees of freedom. All right, so about 0.072. So TCDF 1.604 infinity 9 gives us a p-value of about 0.072. All right, moving on to the conclusion. Conclude. All right, I love writing these conclusions. They're very consistent. They're very just straightforward because I've done it a bunch of times. Hopefully you're starting to feel the same way. Because the p-value goes 0.072 is greater than our significance level, we fail to reject. Or no, our results are not significant. This is happening more by chance than our significance level. So we do not, or we don't have convincing evidence that, and then I can strip the context again, that taking a calcium supplement reduces blood pressure more than a placebo. If I want to be a little more explicit, we don't have convincing evidence that the true mean decrease in systolic blood pressure for calcium minus the placebo is greater than 0. Either one is going to be okay. Okay, so that's going through the 4-step test. Hopefully you were able to pause the video and work through most of that on your own. I'll make one more video summarizing the last part of this lesson.